So we have got on the board, or we've just discussed, the probability mass function, haven't we? We just discussed a way of getting the probabilities given a particular success or outcome. Okay? So if you want, for example, the probability of no outcomes, you're able to use this formula to work out what this probability is going to be. Okay? Likewise, probability x equals 1. You can use this formula to work out this. Okay? And so on and so on and so on. So can I give you 3 minutes to have a go at calculating each of these different outcomes for me? Okay? So for example, if I wanted the probability that x equals 0, okay, I could use the probability mass function. So this, by the way, is f of 0, lowercase f, of course. Okay, I could use the probability mass function. So n is 5 and x in this case is 0, times by the probability, which in this case is 0.6, to the power of 0, times by 0.4 to the power of 5. And then you can work out what that is going to be. Okay, so can you do that for me for all of these different outcomes? I'll give you 3 minutes to have a go at that. Sorry? It is symmetric, absolutely. Okay. So if you think about what this graph is going to look like, you should get something like this. Yeah? So if you have all of these different outcomes, okay? If you think about what the graph is going to look like, if you're going to plot the probability mass function on a plot, you should get something which looks like this. Does that make sense? Yes, absolutely right. Yeah, good. Yep. So what I want to do then, is explore what's going to happen if you change these two parameters. So effectively at the moment, we have a graph that looks something like this. Okay? So you've got a graph that looks something like this. Okay? What's going to happen if you change n and p? So along the bottom you've got x, and the probability, you've got the probability that x equals x. Okay? What's going to happen if you change n and p? So to explore that idea further, if you've got the link on your laptops or you've got something open, go to this link, okay? And it's nice and intuitive. All you have to do is change the parameters along the top and along the bottom. So you see those two sliders, the blue slider and the green slider. Okay, you've got the blue slider here, you've got the green slider here. You can change n and you can change p, and you can explore what's going to happen with the probability mass function as you change those two parameters. Good, absolutely. So at the moment, are you happy this thing is symmetric? Okay. What happens if you change p? So if I change this slider, what happens? It becomes skewed, absolutely. Okay. And it becomes skewed because remember, what is p again? What is p? The probability of success. So if I take it back to 0.5 again, okay, if I take it back to 0.5, are you happy in that case the probability mass function, or the PMF, is completely symmetric? Because the probability of a success is the same as the probability of a failure. Okay? So if I'm doing 10 trials, are you happy the most likely outcome is going to be 5 successes? Does that make sense? Because it's 0.5, right? Half the time it should be a success. Okay? If I start to increase the probability, so I've got more chance of a success happening, are you happy that it becomes skewed towards the right? What type of skew would we call this? Go on. Yes, negative skew, right? It's negative skew. Because I have now a higher chance of getting more successes. Okay, so actually if I have 0.87, it means that 87% of the time I should get a success. So in 10 trials, it should be somewhere around 9. Okay, it should be about 8.7, right? Whereas if I decrease the probability, so I've got a lower chance of success, are you happy it becomes positively skewed? Yeah? Because now I have a lower chance of getting low successes. Yeah? So actually I should only expect 13% of the time to be a success. Yes, Ahmad?
Is that how they measure bell curves?
Yes, absolutely right. Yeah, absolutely right. And in fact, we will do bell curves. We'll do normal distributions. Yep. And actually, you notice this because if I take it back to 0.5, okay, this looks very familiar, right? This looks very, very close to that bell curve. So if you've seen bell curves before, they look something like this. Okay, and we'll look at this in more detail when we do the normal distribution. Okay, this is not quite a bell curve. Why not? What type of variable is this? Discrete. Okay, bell curves have to be continuous. Okay, so actually a normal distribution is the only continuous distribution we look at in this course. Okay, this is a discrete variable, but you can start to see that bell curve coming out. Okay, in fact, have anybody explored what happens if I increase the number of trials? Okay, if I increase the number of trials, are you happy that I'm getting more and more trials? Hence, the discrete is approaching continuous distribution. Yes.
But you mentioned that in this case there is like the training effect.
Yeah, absolutely.
By increasing the number of times, it should change.
So you need to think about that when you're doing your experiment. So in case you didn't catch that, Mohammed said you need to think about training effect or the learning effect of something happening, right? You're absolutely right. In general, if you increase the number of trials in practice, then what you're effectively doing is increasing the chance of having a training effect or learning effect. So there's ways which you can overcome that, okay? You can have different individuals each time you do a trial, okay? That will overcome the training effect quite happily, okay? Yeah, so that's a way of overcoming it. But remember, there's not always going to be a learning effect sometimes. Like this particular situation could be talking about lots of different things. For example, flipping a head or coin. Flipping a coin, so either getting heads or tails. There's no training effect there, right? That would still be a binomial effect. Yeah? Is that okay? Yeah? So increase the number of trials, you get more kind of smoothness happening. Okay, just get more bars. Is that okay? Yeah, any questions? Nope. So, just very quickly then, what do you think the cumulative distribution function is going to look like? So this is the PMF, the probability mass function. What do you think the cumulative distribution function is going to look like? Any ideas? It's going to be a step. It's going to look something like that. Okay? But you notice this is different to the cumulative distribution function, or the CDF, of a uniform distribution. Because with a uniform distribution, each step, each time you stepped up, it went up by the same amount each time because it's uniform, right? Are you happy this is no longer true because it's binomial? Okay? So the biggest step is going to be in the middle, and that corresponds to the fact that the biggest bar is in the middle, the most likely outcome's in the middle. Okay? And then the ones on the outside, the steps are slightly smaller. So smaller, slightly bigger, really big, slightly smaller, slightly smaller. Is that okay? Yeah, any questions about that? No? Okay, good. So you've got that information there, okay? You can use the probabilities you calculated, or they're on the screen. Could you find me the answers to those 8 questions for me? Okay?